Welcome to the DIY Honda Garage channel. The DTC P0138 indicates a problem with the secondary heated oxygen sensor, HO2S circuit, specifically that it is detecting high voltage. This DTC can significantly impact vehicle emissions and engine performance. The secondary HO2S plays a crucial role by monitoring the exhaust gases after the catalytic converter for efficiency and operational integrity. In the Honda CRV models from 2011 to 2016, this sensor helps the powertrain control module, PCM, adjust the air-fuel mixture for optimal combustion. A failure in this sensor can lead to inefficient fuel use and increased emissions, potentially causing your vehicle to fail emissions tests. Before starting diagnostics, it's essential to record all freeze data, clear the DTC, and verify the problem with observation of engine conditions, especially focusing on values that exceed the specified threshold of 1.27 volts. But the error associated with DTC P0138 points to the secondary HO2S, specifically sensor 2. This sensor is responsible for monitoring the exhaust gases downstream of the catalytic converter, ensuring that it is functioning properly. Its readings help the PCM evaluate the efficiency of the catalytic converter and adjust the air-fuel mixture accordingly. The secondary HO2S is generally located in the exhaust system and is connected to the PCM through a 4-pin connector. If the sensor detects voltage above 1.27 volts, it is indicative of a problem. It plays a pivotal role in emissions control, enabling the vehicle to conform to environmental standards. Any malfunction here could result in poor engine performance and increased pollution emissions. When diagnosing the DTC P0138, several potential causes should be considered. First, the secondary HO2S itself may be faulty, causing it to send incorrect voltage readings to the PCM. Additionally, poor connections or loose terminals between the HO2S and the PCM can lead to electrical issues that manifest as high voltage signals. Thirdly, an open circuit in the wiring connecting the secondary HO2S to the PCM could also be responsible for triggering this diagnostic trouble code. Correctly diagnosing whether the problem lies with the sensor, connections, or wiring is essential for effective repair. Each of these potentialities should be methodically checked during troubleshooting to ensure that the root cause is identified and rectified. Common symptoms of the DTC P0138 may encompass various engine performance issues, such as rough idling or hesitation during acceleration. Drivers may experience an increase in emissions, potentially leading to failure in emissions testing, which is a significant concern for compliance. Another prevalent symptom will be the illumination of the check engine light, CEL, on the dashboard, serving as an initial indicator that the vehicle's onboard diagnostics have detected a problem. The driver might also notice reduced fuel efficiency as the engine management system tries to compensate for perceived faulty sensor readings. Recognizing these symptoms early can help in timely diagnostics and repair, preventing further complications down the line. The first troubleshooting step for DTC P0138 involves a systematic verification of the problem. Begin by turning the ignition switch to the on position, which will power up the vehicle's electronics without starting the engine. Next, clear the DTC using the Honda Diagnostic System, HDS, which is essential for resetting the system's recorded error state. Once cleared, start the engine and maintain a steady engine speed of 3,000 revolutions per minute, RPM, without load until the radiator fan activates, signaling that the engine is reaching its operating temperature. Following these steps, check relevant parameters using the HDS. Specifically, monitor the voltage output from the secondary HO2S, Values exceeding 1.27 volts indicate a duplicated failure and warrant progression to the next troubleshooting step. In the second troubleshooting step for DTC P0138, the goal is to isolate the potential failure area. Start by turning the ignition switch to the lock position, ensuring that all electrical power is cut off before working on the vehicle. Next, disconnect the connector from the secondary HO2S sensor 2, which is usually a 4-pin connector. This disconnection allows you to test the sensor independently. After disconnection, connect terminals A and B of the 4P connector with a jumper wire. Specifically, you're connecting the yellow and brown wires. Reapply power by turning the ignition to the on position. Again, use the HDS to monitor the voltage output from the secondary HO2S. If it exceeds 1.27 volts, this confirms that the wiring is functioning correctly and directs you to proceed to the next diagnostic step. However, if the voltage does not meet this threshold, replacing the secondary HO2S is necessary. For the third troubleshooting step associated with DTC P0138, the emphasis is on checking the wiring integrity. Begin by turning the ignition switch to the lock position to ensure safety before handling electrical components. Remove the jumper wire from the secondary HO2S sensor 2 4P connector, which is crucial to return the system to its original state for testing. Once the jumper is removed, connect terminals A and B again using a jumper wire. This time, connect the yellow terminal to a solid body ground to establish a reference point for testing. Turn the ignition on again and monitor the HDS for the voltage output from the secondary HO2S. If the voltage is above the specified 1.27 volts, the wire connections are likely intact, allowing you to move to the next step. Conversely, if the output is less than this threshold, it indicates an open circuit in the wiring that needs to be repaired between the sensor and the PCM. The fourth step in troubleshooting DTC P0138 focuses on ensuring there is continuity in the SO2 wire that connects the secondary HO2S to the PCM. As always, start by turning the ignition switch to lock for safety. The process begins with jumping the SCS line using the HDS. This is a systematic control strategy to avoid any unintended error. Once the SCS line is jumped, disconnect the PCM connector B, specifically the 49-pin connector, to facilitate continuity testing. The next step requires measuring continuity between the test points, with the first test point at terminal number 46 of the PCM connector, and the second test point grounded. A successful continuity test confirms that the wiring is intact, allowing for updating the PCM software if necessary. If continuity is absent, you must repair the SO2 wire between the sensor and the PCM, ensuring proper electrical communication for the system to function correctly. After completing the necessary repairs for DTC P0138, conducting a final repair verification is critical to ensure the problem has been resolved. Start by reconnecting all connectors that were previously detached during diagnostics, paying attention to each connection to avoid any lingering issues. Once all components are reconnected, turn the ignition switch to the on position, powering the systems without starting the engine. Use the HDS to reset the powertrain control module PCM, which is essential for clearing past diagnostic trouble codes and allowing the module to relearn optimal engine conditions. Additionally, conducting a PCM idle learn procedure will help the module to recalibrate its internal settings to match the newly corrected conditions. Once these steps are completed, it's advisable to test drive the vehicle under specific conditions to monitor for any reoccurrence of the DTC P0138. Preventive maintenance is critical for avoiding issues such as the DTC P0138 in the future. Regular inspections of the oxygen sensors, including the secondary HO2S, can help identify early signs of wear or failure, ensuring that emissions control remains effective. Additionally, checking electrical connections periodically can prevent problems associated with poor connectivity, which can trigger false error codes. It's equally important to monitor the exhaust system for any leaks or damages, as these could lead to incorrect readings from the oxygen sensors. Recommendations also include keeping the PCM software updated and following manufacturer-recommended maintenance schedules. This proactive approach helps maintain engine efficiency, performance, and compliance with emission standards. In conclusion, dealing with DTC P0138 involves understanding the implications of a high-voltage signal from the secondary HO2S circuit, which can affect vehicle performance and emissions. Identifying the underlying issue requires a systematic approach to troubleshooting the wiring, sensor, and connections. It is essential to note that clear signs such as poor engine performance or the check engine light will alert drivers to potential issues. Once repairs are made, thorough verification will confirm that the fix is effective and that the DTC does not reappear. Implementing preventive maintenance practices can significantly reduce the occurrence of similar issues in the future. By following these steps, you ensure that your Honda CRV remains in good running condition, minimizing unwanted emissions. Please like and subscribe to the channel. See you next time.